Alrighty, Mr. Gatekeeper here for video 2. And like I said, I am specifically making these for a very, very good buddy of mine. One of my best friends in this life I've lived so far. And I'm going to be speaking on a personal level, but also in a wide-banded sense, because I may actually use these to help other people in the future. I am the type of guy I like to make everything I do resourceful and kill multiple birds with one stone if possible. And I even got a buddy, Mr. Time. He may even want to take a look at some of this stuff. So it's going to be pretty beneficial. And there again, I'm going to emphasize that I want to only relay what's currently in my brain onto these papers and onto this video for a reason. I want to share with Mr. Astra what I know currently in my brain without looking up anything. Basically just to share what I've stuff that I have gained so far doing this that's in my mind without having to look up anything, and just try my best to keep it simple. And I think a capacitor just dropped. I'll look for it in a minute. But anyway, but at the same time, you know, possibly putting some stuff on here that can be looked back for reference, because I plan on sending these to you. Alright, let's jump on in it. I plan on this being a 2-part video because I'm going to bring out a measuring device to demonstrate a few things. But first, let's just go over some notes that I just pre-written. So we're going to be talking about capacitors, and we will be talking about one thing that I did leave off about resistors towards the end that I failed to mention before. Alright, so the majority of the capacitors that we're going to be using with these amplifiers are going to be read in picofarads, PF. You'll also hear a lot of people use the word puff, P-U-F, pretty much for PF. I haven't really adapted that habit myself. I still kind of say picofarad and everything, but some people say like 100 puff, 200 puff. It's just a, you know, extra syllable that you don't have to say. But picofarad and microfarad. Some old codgers, you'll see a lot of older texts, they'll use actually MF, which I don't know why they don't, but they use UF, but it means microfarad. These are the two measurements we'll be using the most, and I guess as you can see they both have in common is farad. That's because the farad is the unit for measurement for capacitors, farads. And farad is the biggest, largest measurement of a capacitor, and it goes down from there. Alright, this is actually the circuit symbol that you'll see in the actual schematic for a capacitor. And the reason why I went ahead and wrote that down on here is because it shows you physically exactly what a capacitor is. Okay. All a capacitor is, bare bone, is 2 metal plates with an insulator in between them. You see how I got 2 pieces of paper right here? 1, 2. If I went and found me a piece of metal that was the exact size of this paper and lifted up this paper, put the piece of metal down on top of that paper, and put this paper on top of the metal, it would then be a capacitor. You could actually read capacitance from it. And I think I actually said that backwards, didn't I? Yes, I did. Let me take that back. Imagine that these two pieces of paper are pieces of metal. I messed that up big time, y'all. Scratch what I just said. Imagine if these two pieces of paper are metal. And each of these lines represent these two pieces of paper. Okay? If these two pieces of paper were metal, then I got a piece of paper that was big as this metal and put it in between both pieces of metal so that both pieces of metal are not physically touching each other but have an insulator in between them. That's a capacitor. You could actually read capacitance from it. That's why I wrote insulator in between here. Two plates with an insulator. That's what this is. That's what this is. That's what that big mama right there is. And this. And that. And that. And give me a second. Let me find this one that fell. Because I do want to show that one too. Hold on a second. I got it. I got it. I got it. Now these particular capacitors that I'm showing you right here, bud, each of these have pieces of metal in them, and also these could have multiple pieces of metal. See, all that has to do with the measurement of the capacitor, how big the piece of metal is, pieces of metal, how many pieces of metal, how many insulators are in between each of the metal. It gets deep, but that ain't what I'm here to explain. But as you can tell, all these are pretty much a flat type capacitor and you can pretty much tell what's going on inside of them. Pieces of metal separated with insulators. Now here's one right here that is a cylinder type capacitor. Every single one of these capacitors you see right here do not have polarities. Okay? There is not a positive or negative. Those type of capacitors do not have polarity. But there are capacitors that do have polarity. And these type of capacitors are pretty much made to hold a charge, to hold electricity in. Just like the capacitors that we use in our audio systems, Astra, back in the days, those are big honking capacitors. Those are farad, like 1 farad, 2 farad, 10 farad. Those are big boy capacitors. You don't use them in circuits. Those are made for holding huge charges. We won't be using them. But this right here does have a polarity. And as you can see, this is something that I've always remembered. It was real easy for me to remember. It actually tells you which side is negative, you see? And all you always have to remember is just look for the side that's striped and has the arrow pointing, and that's going to be your negative. Another indication is, and you'll find this in LEDs also, whichever leg is the longest is the positive side. See how the leg, the shortest, is negative? Yep, that's how they're indicated. Alright. And as you can see, these are different capacitors with different types of packages. And these are pretty much the type of capacitors we're going to be using in our circuits. That's why I have them here with me now. Alright. Now here is just some facts for you. We haven't covered DC and AC voltage yet, but just some facts. DC voltage cannot flow through a capacitor in series, meaning the voltage cannot flow through it. Okay, it can only be charged with it. It cannot actually flow through the capacitor, but AC can. Since AC is an alternating current, it actually creates an electromagnetic field, which helps to create an electric field on the capacitor. So these amplifiers that we're going to be building are RF amplifiers. RF is short for radio frequency. Radio waves are alternating. This is what radio waves look like on a circuit diagram. So since radio waves are alternating, radio waves is AC voltage, it's alternating current. Okay, so that's why RF can flow through capacitors in series. You can take one of these capacitors right here and put it right in line with your RF, and you ain't gonna lose anything. It'll be coupled, but we'll get into all that kind of stuff later on. And basically that's just what I'm showing you right here. DC cannot flow through a capacitor in series. It can't happen. AC can. That's something that's pretty important, and it's something I didn't learn until later on in the old game. Alright, here's some more measurements that we'll be looking at, and you'll be seeing a good bit. This and this are the ones that you'll be seeing the most. Okay. A lot of these capacitors, let me show you an example. Take a look at this capacitor right here. See how it says 104Z? Alright, what that 104 stands for is 1 0, then add 4 more zeros to it. So a 104, 1 0, then add 4 more to it. 1, 2, 3, 4, and that will be 100,000 picofarad. So a 104 is a 100,000 picofarad. But since that's so big, we don't normally say it like that. We're going to say it like this right here. It's a .1 microfarad. I don't ever use anything bigger than that normally on the RF circuit. So we're talking about the most common things that we'll be using. So a 104 is a .1 microfarad. This is real simple. You just have to remember, if 103 is 1 0, then add 3 more zeros to it. So 103 would be 1 0, then add 3 more, a 10,000 microfarad. 102, 1 0, add 2 more, 1,000 microfarad. Now I normally just say 1,000 microfarad. I don't normally say 102. I normally just say 1,000 microfarad. And also the 101, we just say 100 picofarad. We don't normally just say 101, we say 100 picofarad. But that's, you will see this, and you could even see some stuff like this right here. .204, which this ain't common. I'm just giving you an example of the way the mathematics work, and that would just be a 1, 2, 3, 4 picofarad capacitor, 20,000. I actually have a couple of these. Of course, I call them 0.2 UF caps. So one of these equal 2 of them. See what I'm saying? Alright. And on these smaller capacitors, which I didn't write this down, but I'm about to now. Let's see, did I even bring any? I don't think I did. Let me show you these capacitors. See how that says 1,000? That's a 1,000 picofarad, okay? See how that says 140? That's 140 picofarad. See how that says 680? That's a 680 picofarad capacitor. And whenever you see a capacitor that looks like this right here, you can already tell that these capacitors are used in radio frequency circuits. These capacitors are specifically designed for what we use them for. Capacitors like this are more general purpose, like these. These are called ceramic disc capacitors. Ceramic disc. I wasn't going to really get into actually naming all the capacitors for now. We'll get into more of them details later on. If you take a look at this one, that's a 330, a 330. And here's a prime example of what I wanted to show you. Now you see how it says 330, 330? I think my thing's messing up on me. Alright, well you also can see these capacitors wrote out like this. Something like that. Or something like, or some crazy letter or something behind it. Let's see, do I have any that's got like a letter behind it, you know? Like you saw the way these 104s are right here. It said Z. Okay, I think I don't know what the hell that Z means, but I know it's a 104. You'll see this a lot. What this means is this. Going by this same system. Both of these would be a 3, 3, 1. That's telling us to add 1 0. See? See what I'm saying? And usually you're going to be able to tell this. Sometimes this can get confusing. I'm about to show you how. Why? Because a lot of times it'll just be written out 330. But sometimes I've got a lot of 330 picofarad caps that are written out like this, 331. But just like the 150 picofarads, add 1 0. Oops. And a lot of times when you see something like this, you're probably going to know that that's what it is, because 9 times out of 10 it's not going to be 151 picofarad capacitor. It's usually always going to carry with a 1. But sometimes, this is very confusing, and the funny thing is I actually bought these capacitors thinking they were thinking they were 150 picofarad capacitors. Now, different capacitor companies do these things differently than others. At first glance, this looks like a 150 picofarad capacitor, because usually whenever you see a 150, it means 150 picofarad. This particular company, though, whenever you see a number like this right here that has more than one letter to the right of it, like 150J03, whenever you see more than one digit after the number, then they're going by this system up here. So could you guess what kind of size capacitor this is? It says 150 J03. 03. Can you guess? I don't know why they do this. It's so stupid. This is a 150. Add 0 zeros. So this is a 15 picofarad capacitor. And yes, I bought like a bag of 100 of these thinking they were 150s for my preamp circuits, and they ended up to be 15s. This doesn't happen much. I've caught on to it now. Whenever I see this company with like this right here, a multiple to the right, it's always going by that system. So I'm not going to get 150 from this company unless it's written out like this. See? JO3. And then I'll know that's 151, which is 1, 5, add 1, 0. See? I think that's enough of that, man. All right. Let's get to the good stuff. Light me up a stove for this one. I'm about ready to stand up here in a minute. I'm going to stand up when I get the measuring device out. Alright. Here's part 2. Alright, I'm just going to list the most common values that we'll be using. Alright, the most common values that we'll be using with these builds are 8 values. 10 or 15 picofarad, 100 picofarad, 120 picofarad, 330 picofarad, 150 picofarad caps, 1000s, 103s, and 104s. I think somebody just coughed big time. Alright. This is a pretty unique one, which I probably shouldn't really even show, but for the fun of it, I am. You'll be able to do stuff like this once you get all this kind of memorized in your head. Look at this odd capacitor. It says dot 0022K, dot 0022K. Of course, I could just put this on a capacitance meter and know what it is, but do it like this, dot 00. Let's look over here, dot 00, 102. 102 is a 1000 picofarad capacitor, right? Well, that means this right here is a 2000 picofarad, but since it's 22, this right here is a 2200 picofarad cap. I actually use these now for my 1-pill amps and my driver circuits. Good little capacitor, and I got a whole lot of them. I will probably be using these for the rest of my life, because I only need one per thing, and I've got like 500 of them caps, so that's like 500 amps. But anyway, so yeah, we're done with that page. I actually went back to that page. Alright, I'm just going to try to zoom through this real quick. This is going to go over series and parallel, basically saying what happens when we take these capacitors and we put them together, or resistors. I'm covering, I'll be done right after this, babe. This is the part I was going to tell you that I left out about resistors. Okay, and you'll find out that resistors and capacitors are opposite the way they react. All right, if we take these capacitors right here, these two 104s, and we just twist both of the legs together, I think these are already twisted like this when I grab them. Trying to hold it with my dang. I'm so cheap, I got a dang super glue foam cover that I made. I seen some kid do it on eBay. I mean YouTube. Alright, so if we sit here and put both of these bad boys together right here, they're in parallel. Okay, and since they're capacitors, they're just going to add together. So these are two 104s, 100,000 picofarad. So now they're going to be 200,000 picofarad. They just add together. Okay. Now with resistors, it's the total opposite. For example, if I think I actually brought a 100 ohm resistor with me this time. Oh yeah, here they are. Here's a couple more components I brought with me. Oh, here's a prime example right there. That's why I brought that. See this? This right here is two 500 picofarad capacitors. So since they're together like that, that is a 1,000. They just add together. 1,000. Here is a big old ceramic disc 150 picofarad cap. Let's take a look at it. Somebody else is wanting to take a look at it too, I see. Let's see here. See how it says 150, 20%, 6 kV. So that's another thing I forgot to even list on here. Remember when I told you that resistors have tolerances? Well, capacitors do too. It's the same exact thing. Since this particular capacitor right here has a 20% tolerance, which really sucks, but that actually may be a good thing for somebody if they're wanting a good range of capacitance, 20% below 150 and 20% above. So that also could be a good thing. But so this capacitor could be 150 picofarad or 20% up above 150 or 20% below 150. Most of these that you see we use. Now here's a good example of the 121. There it is. Take a look at this. See 121J03. There's that 3 digits. It's going by the numerical system, so that's a 1, 2. The 1 means add a 0. So that's a 120 picofarad capacitor. Ah, crap. Sometimes I enable this shit right here, man, and I do not know how to unenable it. I don't even know. I think it's actually a dang glitch, because I don't know any reason why you would want to have something like this. I was kind of wanting to record this whole video. You're kidding me. It disappeared. Dude, I swear to you, out of all the years I've been recording, whenever that happens, I have to stop the video and start recording again. And I was really wanting to record this whole video without having to stop, so I wouldn't have to spend an hour or two merging it together. Now that's cool. That's cool. Alright. So, resistors, when you put them in parallel, they don't add together. So if you took two 100 ohm resistors, and I could have swore that I brought 100 ohm. Yeah, I did. Here it is. There's 100 ohm. Brown, black, brown. Big boys race our young girls, but violet generally wins. That's a 1, 0, and then add a 0. 100 ohm. If you took two 100 ohm resistors and put them together in parallel, it would equal a 50 ohm resistor. That's easy to do, but once you get past more than one, you have to use a formula. You have to use a calculator. You got to. Now, here is the formula right here for paralleling resistors. Here's the formula for seriesing capacitors. You see how they're backwards? If you series resistors, they add together. If you parallel capacitors, they add together. So they're the opposite. Okay? Let's go to this capacitor example. Alright. Let's say our capacitors are 150 picofarad capacitors, okay? And we have 3 of them. So if I wanted to put 3 150s together in series, and you're probably wondering what would that look like, capacitors in series. Here, I'll show you. Those are 2 capacitors in series. See how one leg of the big capacitor is right here? The other leg connects to one leg of this capacitor. Then see how that leg's free? Series. Two capacitors. If I took these 2 legs and connected them like that, it would be series, like a circle. 3 of each capacitor. Just making sure you didn't have any of my stuff, buddy. Jugger strong my dang switches and relays there the other day. So here is the calculator formula. I remember back when I wanted to figure this out. See, I've used this formula so much when I'm tuning amplifiers. Oh my God. Hand me that. He just got that choke. Get on somewhere, boy. This is not stuff to be putting in your mouth. No, bad boy. No, bad boy. Bad fits. No, no. Get down. I'm almost done with this video. Alright. Get down. So anyway, with tuning amplifiers, I have to take all kinds of different capacitors, put them together. I finally memorized this formula, I don't know, 2-3 years ago, I guess. This is the formula that I learned. I'm like, man, how am I supposed to put that together in a calculator without having to write something down? And I'm the type of guy, when I grab my calculator out, I don't want to have to write something down on a piece of paper. I want to figure out how to do it with one line. This is how you do it with one line. You take your calculator, do 1 divided by, open your parentheses, do 1 divided by your capacitor, which is 150 in this example, plus 1 divided by 150, and then in your parentheses, and then hit equals. So 2 150s equals 75. See, that's easy. They just divide themselves. You see what I'm saying? But once you get more than 2, see, the only way this is going to work out to where they divide themselves like this, if they're the same value. For the resistor, it gets a little bit different. It doesn't work out quite like that. So here is, let's say we have 3 150, using the same number, 3 150 ohm resistors in parallel. Okay, remember, if you parallel your resistors, they get smaller. They don't get bigger. 1 divided by, in your calculator, open parentheses, 1 divided by 50, plus, you just keep doing the whole thing, except it equals 50 picofarad. See, this, I had a mentor of mine, his name was Stickman. And this guy was amazing, dude. This guy really helped me get to new levels in my hobby and understanding. Took time to talk to me, even though how busy he was. He used to tune a lot of his 6-pills using 3 of these right here. 3 of these big boys. So when he sat there and took 3 of these, when he needed 50 picofarad, he took 3 of these bad boys. It made the capacitors stronger. That's all I'm going to say for now. Because the more capacitors you put together, they're going to get stronger. Now he's over here chewing on my dang cigarettes. I tell you what, man. I'm going to chop his dang batteries off. Alright, here. You ain't going to be eating on my dang papers. I need to send my buddy Astra. Alright, man. I think we pretty much killed it, man. So I am going to press pause, and we are going to walk over here, and we're going to use a measuring device to show you how to measure these bad boys. Alrighty, here is my very first capacitance meter, and a lot of these type meters, they do read more than just capacitance, or you're gonna have to get down, bud. Okay, get down. Sorry about this, he likes getting on top of here. But they'll read more than just usually one thing. They'll read, you know, like this one reads resistance. It reads diodes and other things, but we're going to be looking at capacitance and resistance. Okay, this particular meter doesn't have a automatic zero off on it. But before I'm about to measure, as you can see, we've got it on the PF setting, picofarad. And I'll just kind of play with it and get it right there. I normally don't use the PF setting. As you see, it only goes up to 200 picofarad. I'll normally go down to this setting right here, which I can read up to 2,000 picofarad right here. But just for the sake of letting you just see this picofarad, we're going to hook this capacitor up. In 1 minute. Alright. I just hooked up this 120 picofarad capacitor. Now take a look at what it's reading. 117.8 picofarad. So this is a prime example. These capacitors are 5% tolerance. So just because it's a 120 doesn't mean it's going to actually equal exactly 120 picofarad. It can be 5% up or 5% down. And a lot of times it doesn't matter to you. You know, it really doesn't matter. That tolerance doesn't affect you. But I'm a precise cotton picker, and when I go and get my capacitors to build my amps, I've already sat there and spent hours going through a whole bag of 100, 200, 1,000 of these and matching them. Meaning I'll have one bag that all equal 117, I'll have another bag that all equal 118, 120, 121, etc. Which I didn't even have to add that in there, but you see what I'm saying. Alright. Now, let's hook up these two capacitors that was in series. I don't think nothing's wrong with these capacitors. They are used, but let's see, I don't think they're damaged. Okay. So that's two capacitors in series. If I had a calculator, I'd do the math, but 110 picofarad. What was this? Oh, that was at 15. Let me hook that real quick. Or better yet, let's stick it in the old holes here. I'm pretty good about hitting the holes usually, but not today. There we go. So I actually stuck this capacitor right here in the little holes right there, which I don't normally use them. I always like to use the alligator clips, but just to show you, remember it was a 150. Look at that, 15.4 picofarad. See, I remembered it. I know now. You know, I didn't 2-3 years ago. I'd have looked at that and thought it was a 150, which most are. But just remember, if you see them 3 digits after, they're going by the numerical system. So it's a 15 picofarad capacitor. All right, I think that's enough for capacitance. Let's read some resistance, and I got something pretty neat to show you, Astra, which I did not have with me last time. This right here is a resistor. But what's unique about it, of course, it don't look like nothing like these, does it? This right here is what you call a variable resistor, or a pot for short, or a potentiometer. You may remember these back in the old boxes, the old freaking boxes, the old Pandora's box we tried to make that one time. You know, like volume knobs, etc. Those are all variable resistors. This right here is the size resistor that we use for our pots on the front of the amps, on the driver amps, the smaller amps, so they can have a little bit of control to turn the amp up and down, which is just I won't get deep into it, but it's basically just putting resistance. And so that's another thing about resistors, Astra. It is what it says it is. Resistance is putting resistance on things. So this right here, for example, I could put 10 volts through this thing, just as an example, and vary the pot right here. And this is just a pot, you know, this is just an example. I could put 10 volts going in it, and out of it, it could be 8 volts. It could be 6 volts. This is just an example, because I can vary the resistance that it's putting on it. Alright, let me change my leads right here real quick so we can hook up resistors. Alright, let's go on to the resistor setting. Alright, before I hook that pot up, let's go ahead and hook this up real quick. I'll try to be real quick so you won't sit there and be looking at that yellow top. Alright, I just hooked up the black brown, the 100 ohm resistor. And take a look at that. 102 ohms. See, that's a 5% resistor. That's what that gold stripe means. It's 5%. So it can be 5% one way or another. That's a 102 ohm resistor. Let's check this one out. Here's a good example. Alright, now I'm hooking up the 10K. If you remember correctly, 10K is 10,000 ohms. Uh-oh, it ain't giving me a reading. That's because I'm on the 200 ohm reading. 20 ohm, 200 ohm, 2K. And see, if you don't never know what type of resistor you have, if you get up to something where you're not seeing no resistance, and you'll just pretty much start slowly turning it till you do get a resistance. So now I'm at the 2K. I still don't have a reading. The 20K. Now I got a reading. 9.82 kilo ohms. See the K ohms? So that's a 9.82 thousand ohms. Close to 10K. And as you can know numerically, this is 5%. The bigger the resistor gets, the bigger the sway can be. You know, if you had a 1 mega ohm resistor, which that's 1,000,000 ohms at 5%, that can be a pretty big sway. Alright, I'm going to go ahead and finish up the video with this. The old variable. 1 second. 1 second, please. Alright, let me put it back on 200 ohms. Okay, I've got to get this. Let's see. I've got to figure out a way to get this on video while I'm turning it. Let's see if I can't zoom in. Let's see if I can't hold it. Hopefully you can see that. That's all the way down. As you can see, it's at 3 ohms all the way down. Turn it up just a little bit. We're at 10 ohms. A little bit more, 22 ohms. See, it's just slowly going up. So I don't know if you're catching this when I'm holding it with my dang neck. Turn it all the way up now. And all the way up, this one sits at 106 ohms. See, it's a slow variable process. Of course, you would mount this on the box and then put a knob on it so the person can turn it. And the cool thing about these knobs right here, brother, 9 out of 10 other builders out there are going to be using a pot that costs them $7 to $12, $7 to $12 a pot. That's one of the, that's one of the most expensive parts of the box at that point, since that part costs that much. These right here were built in Russia. These things are built like a damn tank. $2 a pot, brother. And I'm the only one I've seen using these, because I bought up every damn one I could find. Those are the type of deals, man, if you find it, you better go ahead and spend all the money you can find on it, because it is going to help you save money from that point on. And not only that, this is actually great quality. So you're getting a part that's just as good quality of the one you've been buying that everybody else buys, if not better quality, for a fraction of the cost. Little things like that is what allows you to build an amplifier, beat everybody else's price, still be as strong, if not stronger, and make more profit. That's what this is all about, man. Alright, bud. That does it for our capacitor lesson. I don't know what the heck the next lesson will be. When I get into the inductors, which is read in Henrys. Henrys is the measurement for inductors. I'm going to be getting into a very important part, which is the transformers. Without them, there is no amplifier, bar none. And so I might be doing that next. I'll go ahead and get into them. And after we do a couple of these, after you've learned all about these parts that I'm actually using to put these things together, then you're going to be able to watch me actually build an amplifier. You'll be actually the very first person to ever watch me build a whole amplifier from start to finish. I've made a few videos of me building amplifiers and steps, small steps, but this is different. I want you to watch me every move, just like you're sitting there with me. I want you to watch me build the whole amplifier. And I'll go ahead and tell you right now, this is the saying that I say and a lot of other guys say. Anybody can build an amplifier. Your mama can build an amplifier. Some of the best amplifiers that are out there right now were built by women. Texas Stars. There's more Texas Star amplifiers out there than any other amp than what we do. 80%, if not more, of Texas Stars were built by women. Yes, anybody can build an amplifier, but not everybody can tune one. And that's something we'll be talking about in the future. Tuning is kind of like what builders act like is the black art. It's the thing that no builder shares with another person. Tuning is that thing that you only get through going through the blood, sweat, and tears. It's the thing that you can only get by putting your hands, on the amplifier and blowing components up and learning And I'm still learning, man. I'm still learning about tuning and better ways to tune. Tuning is one of them things that not even my buddy Stickman would show me how to do. I've never had anybody actually show me how to tune an amplifier. I've had little bits and pieces here and there when I was getting into it. But guess what, brother? I'm going to show you how to tune an amplifier. And if anybody else is watching this cat and pig right there, they're going to be like, oh my God. I don't care, man. Me and you tight like neck bone. Whatever I know, you know. Each one teach one, son. The gatekeeper said it, and I'm gone. Bye, bye, bye.